o'clock and I don't want to keep anybody waiting. We are going to be recording this, so this video will be sent out to everybody that is here or that registered via email, or you'll also be able to find it uploaded onto our ATRA YouTube page. We're going to go ahead and start with some introductions. First of all, my name is Gabriella Soto-Vélez, and I'm a sustainable ag specialist from Fort Myers, Florida. So I serve the Gulf states and the Caribbean territories. And then I'm also here with my colleague Hakeem, and I'll let him introduce himself.
Good afternoon, everyone. I'm Hakeem Holmes. I'm also a sustainable ag specialist with the National Center for Appropriate Technology. I'm from the self-proclaimed city of Southern Charm, Marietta, Florida, but I currently stay in Tallahassee, Florida. So I cover the Florida, Georgia region as part of the Gulf States team. So I'll be here in the background if you need anything. I'll be scouring the chat to answer any questions or provide any assistance.
We also have Elliott Toevs from Echo, so I'd love if you could go ahead and introduce yourself, Elliott.
Yeah, hey everybody. My name's Elliott, and I am the Deputy Director here at Echo North America in Fort Myers, Florida. Originally from Idaho, grew up in southeastern Idaho, but been working here at Echo for 10-ish years, and as well as being the Assistant and Deputy Director, I head up our Appropriate Technology Department.
Awesome. Thank you for sharing. So the way this is going to work today, it's pretty simple. So Elliot and I actually recorded a really in-depth video at Echo Global Farms together, a really how-to so you can see it more than just looking at some slides. So we're going to go ahead and play the video. It's about 11 minutes long. And during the video, if some questions pop up, you can always type them in the chat box and either Elliot or myself will respond to you. But after the video is finished, you can also have a live Q&A with Elliot as well. So I hope that this is useful and fun for everybody. Don't hesitate to ask any questions. And I'm going to go ahead and get the video rolling. So you can go ahead and let me know if it works. All right. Here we go. All right. Looks good, everybody?
Yes, ma'am.
Sweet.
Hey everyone, welcome to Echo North America Regional Impact Center. My name's Elliott Toevs, and today we're going to learn a little bit about biochar. So there are three main benefits of using biochar in agricultural systems. First is increased water holding capacity. Second, increased nutrient holding capacity. And the third would be an increased microbial life in the soil. I like to think of it a bit like a sponge. So the porosity and the surface area to volume ratio helps us with water holding capacity, just like a sponge would, but it also helps with nutrient holding capacity, boosting both our anion and cation exchange capacity. Then all that surface area is great for our microbes to live on and boost beneficial microbes in the soil, which we'll touch on later. As the appropriate technology specialist for Echo, I seek to find appropriate materials to build a biochar kiln. Anything that we're using needs to be readily available, ideally low cost, and easily reproducible. So today we're going to look at making biochar with a top-lit updraft kiln made of a recycled 55-gallon barrel and some sheet metal. Our recycled metal barrel is 55-gallon drum. The one thing that we have to do to make it a good kiln is we need to add holes in the bottom of the drum to allow a little bit of airflow to keep the process of pyrolyzation going as we're making the biochar. To make the holes in the bottom, we use a 3/8 drill bit spaced somewhere around 1 inch to 1.5 inches between holes. I usually just do it on a grid pattern. Something that has consistent hole spacing is best to get the most uniform airflow as possible. When selecting biomass for the feedstock to make biochar, it's important to look around you, find what's available. For us here at Echo Global Farm, we have an abundance of bamboo. When I select biomass, I want to find stuff that's already dead, plant matter that's already completed its life cycle. This is in order to capture the most carbon. We don't want to be cutting down green living plants that maybe are still capturing carbon, but once it's died and now the carbon is being released back into the atmosphere, if we can capture it at that point and then pyrolyze it, we'll get the most carbon sequestration. Within our clump of bamboo, we've got living, healthy culms, and then dead culms that just naturally senesce over a period of 7 to 8 years. Once they're dead, we go through and start culling them out. So I'll just cut it down and cut it into sections and split it for my biomass. After you've cut down the culm of bamboo, the next thing is to cut it into smaller lengths. And when you're cutting it into the smaller lengths, just make sure you're cutting it slightly shorter than the barrel. We don't want it to extend past the barrel when we put it in the barrel because we're going to have a chimney on top that needs to sit on top here. So just a couple inches smaller, and then we'll split the bamboo and stack it in the barrel. One of the nice things about bamboo is that it's really straight grained and tight grained, so we can split it very easily down the middle. So I just have my bamboo machete here. I'm going to cut it down the middle here, and we'll split it in half to load it into the reactor. Once it's split, I want to make sure I get all the branches off so that they stacks nicely in the barrel. Once we have our bamboo cut to size and split, we can load it into our kiln. We're loading our bamboo vertically down the barrel. So the easiest way to do that is to tip the barrel on the side and stack it in. As we're loading the feedstock and selecting feedstock, it's also important to make sure that you have fairly uniform size. If there's differing sizes of feedstock, the pyrolyzation will happen at different rates. And then it's difficult to control in a simple system like this. So the more uniform the feedstock, the better. One of the things that research is showing us is that not all biomass and biochar is created equal. So for us, our feedstock is bamboo. It's readily available here. Many people are looking for hardwoods to char, which hardwoods can make great biochar, but they're not necessarily readily available. Each feedstock will have different physical and chemical characteristics in the end, and they will vary on pH and cation exchange capacity and percent carbon. So it's important when you're doing your selection process for your feedstock, you can look up some research and see some of the generalities of what feedstocks might produce what quality of biochar. To prepare our site for our kiln, I first dug a hole around here slightly larger than the diameter of the barrel. And then I've placed some small bits of brick. You can use stone, anything that keeps the barrel up off the ground. We need to allow a gap there for that airflow. I've also got a mound of dirt around the barrel, and that'll be important once we've started the process to control airflow to keep uniform pyrolyzation throughout the barrel. For a top-lit updraft kiln, we light the fire at the top. Now for us, the biomass and the fuel are the same. The bamboo is going to feed the fire and generate heat. But as the heat begins to travel down into the barrel, it's going to be oxygen limited and not full combustion will occur. The combustion process will happen up top. So the pyrolyzation process will begin as we start to go down into the barrel. When you're selecting a site to make your biochar, make sure to find a place that's open, no risk of starting a fire around you. My colleague Leah watered the ground around this before we start. There's potential that some embers may come out the chimney as it's going. So just make sure you're in a wide open space where there's no risk of fire. Also, it's a good idea to have some water, buckets of water available, or even better, a hose nearby that you can quench any fire that may start. We'll also need the water to quench the process once it's done. Once we've got our kindling on the top, we can go ahead and light it. And you can use matches. I've got a little bit of a torch here to help us speed up the process. Once we've got it lit, we're going to put these bars over the top to allow for a secondary air gap before we put on our chimney. I have slots cut in these so that they don't roll around, but you can use square bars if you've got them. And then we'll place the chimney on top. The pyrolysis process happens in an oxygen-limited environment. So it's thermal decomposition of organic matter in a low oxygen environment. So what's happening right now is as we're building up that heat from this initial flame, we build up coals and embers on the bamboo itself. And that heat will continue to travel down the barrel. As the heat travels down further, we enter that limited oxygen environment. Even though there's a little bit of oxygen coming through the bottom holes, it's not enough to allow complete combustion to occur. So you'll only see the flame at the top. This is called a flame cap, and it prevents too much oxygen from interacting with the feedstock during the process. This allows us to create actual char versus ash. So as the burn is starting, we can already start to see heat traveling down through the barrel. We want to keep that heat uniform as possible, the heat transferred down the barrel as uniform as possible so that the pyrolysis process will happen at the same time. Otherwise, we'll end up with half of a barrel that's completely turned to ash because the process has gone too far beyond pyrolysis into complete breakdown, just left with ash. Or we'll have unpyrolized product at the end. So I will manipulate the airflow using a shovel and try to add a little bit of dirt around areas that maybe the air is flowing a little bit faster than it should. All in an effort to keep that nice uniform heat flow going down towards the bottom of the barrel. So as we're waiting for this to complete its pyrolysis process, I thought it might be a good time to just explain a little bit of differences between char. So char is the general term we use, and it could be either in a form of charcoal, which would be for fuel, or biochar, which we would use for a soil amendment or carbon sequestration. Although in its form, raw form char, you could use it for either. I typically warn against just buying charcoal off the market and using it as biochar because there are some pretty important quality characteristics that we're trying to get with biochar that we don't necessarily need with charcoal. So when you're looking for biochar, good quality biochar, we want to find something that has a very high surface area to volume ratio. It has a high porosity, and it's been made in a process that can reach temperatures between 500 and 700 degrees Celsius. At this point in the process, you can see the heat has traveled about 2/3 of the way down the barrel, meaning all of this here is already going through that pyrolization process. We've got about 1/3 of the barrel left, so we'll let that heat travel all the way down to the bottom before quenching. We're nearing the end of our process here. We can tell that because we have the heat discoloration that's gone all the way down to the bottom of the barrel. We also can see a glow from the bottom of the barrel coming out those holes. Good indication that pyrolysis has happened all the way through. Our flame has really died down. Now it's time to quench it. At this point, it's time to quench the flame and stop the pyrolysis process so we don't go from char and continue on to ash. I'm going to use some buckets of water. At this point, it's really important, safety, very hot. As I'm putting that water on there, it's going to generate a lot of steam. So when I'm pouring, I want to stand back away from the opening of the barrel. So this is our final product of the biochar, uncharged and uninoculated yet. But what we're looking for You might still recognize it as bamboo. It's taken a different form though. It should be light, it should be easy to break apart, almost have a glass-like sound to it as it hits together with other pieces. We can also test the conductivity of the biochar to test for a very baseline quality. If it conducts electricity, we know that it's reached at least a minimum quality threshold. The next step in the process is to crush the biochar. We want to crush it down almost into a powder form, really. It can be almost a dust. Crushing can take a variety of forms. I'm going to use a mortar and pestle, a mechanical grinder, or other method to crush it can be used. It's not hard to crush, but we need to make sure that we get it down into a small enough size that we've really increased the efficacy of the biochar in the soil. Once we have our biochar crushed, it's time to inoculate it with microbes. Remember, one of the beneficial things about biochar, it's like a sponge in our soil. The porosity, the high surface area to volume ratio gives a lot of surface area for microbial life to populate on. So that can be beneficial bacteria and fungi. In order to inoculate it, one of the easiest ways to do it is if you already have a finished compost pile, incorporate it half and half into a compost pile. So we'll mix this 50% biochar, 50% compost, and then let it sit. Now it takes some time for the inoculation process to happen. So you may want to let it sit for 4 to 6 weeks or even longer if you can to allow the beneficial fungi to really begin to populate. Another way to inoculate your biochar in a faster method is to use some sort of compost tea or worm casting tea. For us, we've got some worm casting tea here. It's bubbling with an aerator. We can put the char in there with a paint strainer, and then we'll let it sit there for 24 to 36 hours. So we can add this to our compost tea and let it sit there for 24 to 36 hours. This will speed up the inoculation process, and then we can take that slurry and apply it directly onto the garden, or we could also apply it back into a compost pile to inoculate with other beneficial fungi and microbes. One of the things that we haven't covered yet is if you just want to charge your biochar with nutrients and skip the process of inoculating with beneficial microbes. Now you can do both, you can do either or, but to charge your biochar with nutrients, we typically look at available sources of nutrients. So in the global south, and people were training in other areas of the world, buying soluble fertilizers may not be an option. And so for us, we often use urine. Urine's readily available, whether human urine or other sorts of animal waste. It's got a lot of nitrogen in it, can pre-charge a biochar with nutrients and then apply it. Of course, you could use soluble fertilizers or other things. This time, the timing of charging it won't take as long as inoculating with microbial life, because it's not a living process. You're just getting a chemical exchange to happen. Once you're charged with nutrients, inoculated with good microbes, you're ready to go for application. So for us, we have a bed here ready to plant, and in our preparation, we'll spread our 50% compost, 50% biochar on the top layer. We can work that in the soil or cover it back up with mulch, but we're going to just apply a nice layer of compost as we go. It's important to note that as you're inoculating your biochar and charging with nutrients, make sure that you're following the USDA organic guidelines for good quality compost and reducing any pathogens. Now we're going to apply our compost and biochar mix over our bed. A nice layer, just like you would apply compost, is a good way to go. The nice thing about biochar is that it'll stay around in your soil versus compost that will break down eventually. Well, I hope you enjoyed your time with me here at ECHO. If you have any questions or would like to explore biochar further, feel free to reach out to us. Look at our website, echocommunity.org, You can post conversation questions in the forum, or you can email us directly and we'll respond to your questions free of charge.
Hi there, everybody. I hope that you enjoyed that video. Did the audio cut out in the end? Ben Roland says lost audio. No? All right, well, that's good. I was wondering if anybody. Okay, perfect. Thanks, Josh, for letting us know. Yeah, if you guys have any more questions, you can feel free to unmute yourself and ask Elliott directly, or if you're a little shy, you can go ahead and write it in the chat box, and we'd be very happy to answer any and all of your questions about biochar and soil fertility.
I have a quick question. I got in a little late on the video. Is there like some way to see this video again?
Hey Royce, how are you?
Howdy.
It's good to hear from you. I'll actually be emailing this video to everybody that registered, and I'll also
Great.
have it posted on our YouTube channel. So I have your email. I'll make sure that I send it to you directly.
Thank you.
Yes, sir.
Maybe just to take one of the questions of looking at schematics or plans for the kiln. I was trying to look in my files here to see if I've got one that's easy to share of this one particular. I don't have this exact model in an easy to share schematic, but there are some other options, other kilns out there that I'll try to share another link here. But the 55-gallon barrel, if for people to get their proportions right, essentially use a chimney that's it's about 8 inches in diameter. And it's the length, basically the same height as the barrel, is the same height as the chimney. And then for that secondary air gap in your between the barrel, top of the barrel and the lid, you want about 1.5 inches air gap there, ideally. And then on the bottom, you want, we do like 3/8 inch holes spaced about 1 inch to 1.5 inches apart, kind of on grid. So if I find a better resource that has this specific one, I will post it in the chat here before we leave, but I can send a couple other links along that might be helpful.
Yeah, that'd be great. Thank you. We have a couple more questions. I can also make you co-host, Elliott, if you have something that you wanted to pull up and share that on your computer. No
Okay.
pressure, but
Yeah.
that is an option. So in regards to the dimensions, that'll be something that we'll address with some of the links that he has. And then we have a comment from Stefan, and he says, I always wanted to try using biochar in my garden, but I'm afraid the biochar might suck up some of the nutrients from the soil. And so he's applying it to release over time. So did you want to touch on that?
Yeah, so good question, Stefan. If you put uncharged or uninoculated biochar on a garden, it is possible. I mean, the best way, kind of like I said in the video, I like to think of biochar is like a sponge. So if you put if you wrung out a sponge or a dry sponge, you put it on a puddle of water on your countertop, it's gonna suck up all that water around it. Same idea with biochar. If you're putting uncharged biochar in your garden, it may actually compete for available nutrients with your plants at first. So yeah, I think the best way or the simplest way for anybody that's doing compost to do it is just mix it in with your compost and let that charge. But if you're if you're wanting to bring in more nitrogen, than yeah, using urine or soluble fertilizer or even compost teas, ways to get other nutrients in there. But I would, yeah, definitely recommend doing some form of charging or inoculating before applying it on the garden.
Thank you for taking the time to answer that. We have a couple more. So Eric asks, what is the difference between this method and one that builds a fire around a closed system?
Yeah, so the biggest difference is we're using the biomass, the feedstock, is both the feedstock and the fuel. So the biomass is both the feedstock and the fuel in this one, meaning you remember the video, as that bamboo is burning down, it's feeding that, it's bringing heat to the process to get that pyrolyzation process going. But it also becomes the pyrolyzed product. Whereas in an enclosed system, we do another type where we have a smaller barrel that has a lid on it with a little hole in it, and you actually put that barrel in that larger barrel, and then build a fire around the smaller barrel. And that one, then the feedstock and the fuel are two separate things. So if you had, for example, a hardwood or something that you wanted to make a really nice biochar with, you might not want to waste your hardwood as your fuel as well. So if I have it enclosed in some other container, I can get a really high yield because all of that feedstock goes to biochar and it is not consumed as a fuel. So that would be an advantage of having a completely isolated system. But it does take a little bit more work, a little bit more material. So just depending on what you have available and then what fuel and feedstock you're after will probably dictate what's the best option for you.
We have a couple more questions. This one is about the quenching water. Are you able to dilute it or reuse it because it has nutrient value? And then we have a question about application rates per acre.
Yeah, good questions. So one thing to think about biochar, don't think about biochar as a fertilizer in itself. It's more a carrier of fertilizer, of nutrients, of beneficial microorganisms. Because essentially biochar in itself is just carbon, merely like inert carbon. So that's why it stays in your soil for hundreds, if not thousands of years. It's gone to just this inert carbon form. So if I'm quenching, that quench water is not really going to have many nutrients in it. It might have, some ash and things like that from like washing off any ash that was on the char. So you could save it for some other purpose, but it's probably not going to be very nutrient. Well, it won't be very nutrient rich. There's not going to be a lot of stuff in it. So we don't worry about capturing that. But as far as application rates, this is highly variable, and it really depends on the soil type. So in general, you're going to find biochar research shows that biochar is most effective in acidic soils with low organic matter and low cation exchange capacity, low water holding capacity. That's where you're going to get the biggest bang for your buck, so to speak. This is where you're really going to see biochar shine. And, in application rates of that, you may be a typical application rate is somewhere that most studies do are somewhere around 4 tons an acre, which is a lot of biochar if you're making it in a little kiln like that, depending on what size of operation you've got. But in general, that's kind of a target rate to shoot for. Now, biochar, again, it's worked well in acidic soils. It's going to have a liming characteristic of the soil, so a liming characteristic for the soil, so it will raise soil pH. So if you're already starting, like here in Southwest Florida, we actually have more alkaline soils, so we don't see as big of an impact in biochar for nutrient availability. It does help with our microbial life, but we actually do not put on like 4 tons an acre here. We don't see the benefit in this side of things other than the microbial life and an increased organic matter.
Awesome. We have a question about using wood chips as a feedstock, scaling up the production. Like they're wondering if you would just use longer bamboo poles, what that would look like. And then Eric was wondering if you could touch a little bit more on the microbial inoculation of biochar. And are there any negatives to using freshly made biochar in the field? Can it cause nitrogen stealing?
Okay. Wood chips, yeah, that's great to use. In this kiln in particular, the challenge is you need enough airflow through the bottom to keep that process going. So if they're tightly packed, and you know how small the wood chips are, if they don't allow air to flow through this kiln in particular, it may be challenging to actually make it in this setup. But you know, like any organic material can be pyrolyzed. So we've pyrolyzed rice husk, coffee chaff, wood, bamboo, also corn cobs. I mean, any sort of biomass, organic biomass can be charred. So it will give different characteristics, and there are some studies that compare some of those. And then also depending on what heat you got to, what temperature you got to in the pyrolyzation process will dictate some of those physical and chemical properties. In general, pyrolyzation starts happening at like 300 degrees C, and the ideal range is somewhere between like 400 to 700 degrees Celsius. But any biomass can be charred. So yeah, use your imagination, figure out what's available in your area and try it out. As far as scaling up that production, there are commercial, like industrial grade, biochar operations, and most of them are capturing. You can notice in our barrel, the flame was going straight out to the atmosphere. Most of them are actually capturing the gases, that they're not just burning them right off. So ours are just combusting in the chimney, but they're capturing those gases that come off of the organic matter and using that to fire the process to be continuing as your fuel to keep the process going. And then they're mostly continuous flow systems. So they're barrel type or something that are just bringing biomass in, and you can make tons a day, but very expensive. A cheaper way to do it a little bit larger scale would be using a trough or trench method. So you can, or a larger kiln called a Kontiki kiln. All of those work on the same principle, where you have limited oxygen environment because you've either dug a trench kind of at a specific V pattern where in the bottom oxygen is not getting to, and you keep adding biomass onto the top. Once you get that process going, you just keep adding more biomass until you basically fill your trench all the way up. It creates what they call a flame cap, so that heat is traveling up and combusting at the top, and it doesn't allow very much oxygen to go down below, but the heat is traveling down lower. So you could scale that up to a fairly large trench or trough, or something. Kontiki kiln is usually a little bit larger, round one of that version. So something that you could still, I've seen some examples of that through vineyards. They'll take all their their vine prunings, and as they're pruning, they're bringing them in, and they just have a big Kontiki kiln going, and they just keep adding it on top. and on top until they fill it all the way up, and they quench it and dump it out and start over again. So there are definitely ways that you can do at scale that aren't incredibly expensive. But if you want to get beyond that, you have to go to some commercial systems. Let's see, there was one more about microbial inoculation. Yeah, so best ways that we typically inoculate are with either in worm castings, compost teas, or in compost itself. You can also find good healthy soil, and especially if you find areas where you get nice like beneficial fungi growing and things like that, take it and mix it in there and let it sit. Depending on how much time you have, will maybe dictate the best way to inoculate. If you're doing this on a larger scale, it's probably going to be best to inoculate it either into compost if you're composting on a large scale, or running it through some sort of process with compost tea, or worm casting tea or something like that. Again, there's two sort of ways you can think about inoculating and charging biochar. You can do both, but one would be more thinking of it on that sort of chemical side of things, putting actual nutrients like nitrogen, phosphorus, potassium, those things into the biochar, or on the microbial level, the beneficial microbial level, which would be more along the lines of those compost teas and things like that. Again, you can do both, like there's nutrients that are going to come from that compost, but two different ways to look at it.
We have a couple questions about using biochar with trees, and so they wanted to know, is there a recommendation for the amount of biochar per tree? And then also somebody is starting a syntropic food forest essentially, and they want to know, is there something better than another to inoculate your biochar with, if it's more of a fungal based compost, or if you have any recommendations on that.
Wait, what was the first one? Sorry, I'm first question.
So we have a question about the biochar per tree for an orange tree, for example. I know those are hard to give those specifics.
Yeah, I guess depending on the size of your tree, I mean, if you think about one way to an easy in, I would say, is if you want to think about maybe how much you apply compost to your tree per year, applying that compost. In that compost application, do half biochar, half compost, and start there. And then, so, what you would put around a tree, do it 50-50. And then, as you see beneficial results, you can add a little bit more and do that next time. But keep in mind that biochar will, you're building up a supply of biochar there in the soil, as long as it doesn't wash away or blow away, because at the point when you're adding it, it's very fine. It's not big chunks anymore. You've crushed it into that fine powder. So as long as it doesn't wash away or blow away, it's going to stay there in the soil. So you could start with some of that, just 50-50 compost, however much compost you put on, just do half of that with biochar and see where it goes from there. But it is, I wish, this is always the biggest question that people have, is how much should I put on? And I wish there was like a hard and fast rule I could tell you, but it's so dependent upon soil type that it's really hard to give a very good idea without knowing the soil type. Okay, the next question was about
so kind of a similar question in regards to starting a syntropic agroforestry system. And so do you have a preference on what you would charge it for the trees? More of a fungal compost, mycelium to load it?
I don't have a lot of experience with I don't have a lot of data or experience to back up specific concoctions or recipes for specific applications like that. So it would be, I can't give you a very good answer on that, unfortunately. You know, I think as you start to see, there are some research articles that I've seen that look at some of the properties of biochar in helping reduce like fungal pathogens, so harmful fungal populations at first, and it helps with seed germination. So if you are doing a syntropic system and you're like planting stuff from seed, kind of in that theory of syntropic agriculture, I don't know if one or the other, you know, fungal, mycelium, whatever that mix you're going to use, some sort of EM. I don't know how much of a difference that would make. I think you're probably going to see a bigger benefit from the suppression of some of the soil diseases at first and helping encourage seed germination. And then as your system starts to establish, that biochar is going to be, you know, this home for all of these beneficials over the years. So yeah, I don't have a definite answer for you, but there are proven benefits to starting it with biochar.
We have a question about feeding biochar to cattle, if that is something that you can do, and is it inoculated or uncharged?
Yes, so I will not be able to give you any rates. I don't know, I don't remember how much they've done studies with feeding biochar to cattle. And there is, you know, a small amount, there is a benefit. And then once you get above that, it becomes harmful, or yeah, you lose the benefit. So there are systems out there that people are incorporating biochar into feed, and it would be uninoculated. It would just be raw biochar. To my knowledge, I don't think there's any that are inoculating with anything. Some health benefits to the cattle. Also, out the other end for manure, you do potentially have reduced nutrient leaching in those areas. So yeah, it is a thing. There are studies on it. I can't point to one specifically off the top of my head, but if you look them up, there are actual research studies that have been done and found it beneficial in small amounts.
I found a study on that on Google Scholar, so I linked it because it's specifically talking about biochar for cattle, and I'm sure in there might be some rates, so that might be helpful for you.
Yeah.
Somebody has pallets. They're wondering if they can use that. So maybe treated or untreated wood would make a difference. I don't know.
Yeah. Depending if the pallets are treated or not, it's more. I usually shy away from treated wood, just because as that is. As the different things that are made to, or put in the copper and things that are made, that are put into the wood to treat it, as those volatiles, it can be not so great for us and the environment. If you're getting a really clean burn, you know, presumably pretty much all of that is combusted, but I would shy away from treated pallets. Untreated, yeah, it's fine. No problem there. But I typically tell people to shy away from treated wood.
Jason has land that has heavy drainage, and he is asking what would make the soil not hold water compared to others.
Heavy drainage, as in it's not draining very well, or that it is draining too well.
I want to say that it's draining well. Jason, do you want to pop in here and clarify so we can answer your question well?
Oh yeah, so my fault. Yeah, my soil's not like you mentioned something about earlier about the soil, I guess not holding water, the biochar to work better in. be more, I guess, effective. That's why I was just wondering. I wrote my sentence a little incomplete. Is it better to use biochar in soil that is a little bit more poor, like a loamy soil, sand, or is it like a regular? Does it matter? Like using a raised bed or seed the planting seeds right into the ground there, where you got a little bit of a pitch. Is there a preference that it works better on, where it holds better and doesn't like drain away hard rain or anything or wash away?
Yeah, you're thinking about the biochar itself washing away.
Yeah, because different part. I'm in New Jersey, so different parts of NJ. You got the loamy soil for the fruit, which is good. And you got the regular, really good fertile soil. I'm just wondering, where I don't want to waste this, the biocharge, the whole process. If it's, if a raised bed is better, but since it's kind of contained, it's better. I don't know. Try to get the best.
Yeah, yeah, good points, Jason. I think my recommendation would be if the soils that you have that are the most acidic and are low organic matter, low cation exchange capacity, the texture doesn't necessarily, it doesn't always hold that one texture is it's more beneficial in one than the other. But I would prioritize those. That's where you're probably going to see the most benefit. And then, yeah, if it is on a slope and you've got problems with soil washing, topsoil washing away, I would try to incorporate it into the soil as much as you could. So depending on if you're doing tillage or not, I would, maybe spread it and then till it in. But if you've got covers on them, cover crop or something like that to keep it there. One of the benefits I like incorporating in compost because if I just incorporate inoculated biochar straight onto a field without getting it incorporated into the soil, it will wash off. If I'm on a slope and the rainwater comes and running off, that biochar floats and it'll start washing off, or in a wind event, it'll start blowing around because it's like a dust. So I would prioritize those soils that I said there, like acidic, low organic matter, low cation exchange capacity. Biochar will help with water holding capacity as well. So if you have areas where you need to boost your water holding capacity in your soil, that'd be a good way to do it. Yeah, hopefully that helps.
Yeah, absolutely. I figured instead of writing another question, I don't mean to interrupt. Thank you for that information. What about if I have to add soil amendments, and then sometimes they ask you to add lime when you're just kind of like finding maybe a new patch of land, a new little that you want to start growing something in, and you may have to add a little lime. Is that lime going to affect the biochar? Like if you're adding certain amendments to it, is there one to stay away from that's kind of like going to counteract the other, maybe?
Yeah, good question. Specific interactions with lime, I'm not sure on. Biochar will have a liming like characteristic in itself, so it's high pH, so it will help raise your soil pH. And so you may actually, in the specific instance of lime, if you got biochar at, a decent rate, maybe like 4 tons an acre is kind of what they generally have done studies on, you may be able to skip the lime. But as far as counteracting in other ways, I think even, if you're applying biochar with other soil amendments, I can't think of one in particular. And if somebody else has an idea, please throw it in the chat. But I can't think of one in particular that would be counteracting necessarily, because the biochar, unless you're putting some acid with it, that you're maybe losing some of that liming characteristic. If you are wanting to bring up your pH, but other than that, I can't really think of anything. Yeah.
Thank you, Jason, for asking those questions. So we have 2 questions to wrap it up. And if I missed your question, go ahead and pop it in the chat. Or if you have anything else for Elliott, go ahead and ask that in the chat as we begin to wrap up. But we have one question about making biochar in a colder climate. The concept is just to use the heat in a thermal sink or rock to store and give off heat over time rather than using this during a warm or hot climate. So that's your first question. And then number 2 is adding biochar to a worm bin. Is that safe?
All right, cool. Yeah. So yes, I would highly encourage you to think about using that heat that it's giving off. That the whole pyrolyzation process, it first is like taking heat. It needs heat to get it started, and then it's going to release heat. And so it's both endo and exothermic. But there's a lot of heat that's produced there. It's great to capture that. So there are a couple of ways that you could do that. Yeah, you could capture it, do some sort of simple, have something high in thermal mass that you're heating up that then will absorb that heat and slowly release it. Like if you were, doing this in the northern climate. But the other aspect would be you can, and one of the kilns that is up on ecocommunity.org is a kiln that it actually captures the gases coming off, so it's not combusting those, it's bringing it back in to fuel the fire more. But you could use that gas to fire some other burner or something that would produce heat. So there are a lot of different options out there. I would highly encourage you to use it because it's something that's a lot of energy just being wasted in the simple kiln that we have here. Of course, the more complex it gets, the more expensive it's going to be. That's our focus is more like the simplest methods. But I would definitely, yeah, great. Thanks for putting that do-all one in there. That would definitely be something to think about. And then the other question about putting it in the worm bin, I think it's fine to add. I wouldn't add tons of it, but it's fine to add some in there, and then it will become inoculated as it goes. Might help absorb some excess moisture if you've got a little bit too much moisture in your worm bin. But yeah, I would be careful about adding too much with the worms themselves. But in moderate amounts, you should see some benefits as far as it'll absorb moisture, and it'll also be absorbing nutrients.
Great. And then we are on to our last question, I believe. Raphael asked, what are the economics of scaling biochar production? Is there a point where the costs outweigh the benefits, making large-scale production uneconomical?
Yeah, good question. An organization that you might want to check out is the International Biochar Initiative. They've got they're a collaboration of lots of different businesses and organizations, people that are trying to do biochar production as a business. And I think from the farmer perspective, you've got to step back and see, am I getting the yield increases? Biochar will increase your nitrogen use efficiency. So you could presumably reduce the amount of fertilizer inputs because you've got biochar to hang on to those nutrients and exchange with the plants more easily. Also, the microbial life that's going to aid in those nutrient exchanges. So there's a point there where you may be able to reduce your inputs, or you should be able to reduce your inputs, thinking about NPK in particular. And you should see some benefit in yields, again, depending on the soil type. So from that perspective, there is there is a point of diminishing returns for the farmer from actually scaling the production from a producer standpoint of wanting to sell biochar. That's going to be really dependent upon what context you're producing. I mean, biochar is sort of this, you know, it's kind of a hot topic now. People are very interested in it, and small scale, like you can sell small scale bags of biochar to the general public for an insane amount of money right now. So it's pretty amazing. You know, gardeners and people are buying it. So it depending on your business proposition, you may be able to make even small scale production profitable. Typically, where biochar production is profitable on a large scale is there's a few things happening. One, there's an excess of biomass that is cheap or free to get. And then two, you're able to use the heat generated from it for some other process like electricity generation, or some other, using that energy in some other way. So a couple of examples just really quickly, or one example really quickly, Southeast Asia, there are operations that are they're rice mills. A biochar producer partners with the rice mill. They're taking all the rice husk, all of the residue, the waste, and they're turning it into biochar. It's a waste product for that rice mill, and it's a cost for them to get rid of. So they're gladly giving it to them to process. Part of the deal is that they process it and they give energy back to the mill. And then they've got free input, they've got free essentially biomass to turn into, and then you are able to sell your product. And there's a whole nother market of carbon markets where this is capturing carbon, and we haven't talked about that a lot here with carbon sequestration, but there are also incentives in capturing carbon. And so there are a few different ways to look at it, quite a few different ways actually, and quite a few different models. But those would be some of the things you got to look at just to determine profitability.
Awesome. And then we have one last question about wood vinegar. So has anybody ever tried making wood vinegar in the process of making biochar?
Yes, good question. So in this one, we're combusting all of the gases, all of those volatiles that have come off of the bamboo or whatever feedstock. So no wood vinegar is being produced in this specific model you saw in the video. If you click on that link that Gabriella sent on the chat, the Dual Biochar, that one is a big value of that one is producing wood vinegar. So this is from our office in Chiang Mai, Thailand, and farmers there use wood vinegar for all sorts of different things. So it's actually a value-added product for them. So biochar at some points is almost a byproduct for them, and the wood vinegar is more valuable. But yes, wood vinegar can be used for pest protection, all sorts of different cures and things for agriculture and otherwise. So depending on if there's a high value for you in wood vinegar, I would recommend looking at that other kiln. There are also simpler ways to do it, but that one is a good way to get started.
Wonderful. Well, does anybody else have any other questions? Or if not, I think we're going to begin to slowly start wrapping it up. And just remember that we will send this recording with the video and all of the questions and answers as well out to everybody that registered. And it'll also be on the ATRA YouTube page. But I would be happy to answer any last questions if there's anything, or otherwise, we really appreciate you sharing this hour with us and asking really great questions. And thank you so much to Elliott for sharing your time when making the video and for all of your knowledge. It's been so valuable.
Thank you all. Yeah, it's great to be here. So thanks for
Can I ask one question?
Yeah.
Or one question and a half, maybe. So if I dig it into the whole, production market of wanting to sell some biochar, is there a shelf life depending on how you package this? So, you say package it in like, the way soil's packaged or, mulch bags, and you're sealing it airtight. I mean, especially if you're shipping this maybe across the country, is there maybe a shelf life where you have to worry about that you'd have to put on your label, or it's just, because once they inoculate it, I guess that would change it too, right? I mean, once you start adding it to your soil, can you guarantee by the time they get it, say, 3 days shipping or whatever ground, say they use ground shipping, 3 to 5 business days or whatever. Is there, depending on the amount you're shipping, would it be best to stay at a lower volume maybe than a higher volume, or?
Yeah, that's a good question. I am not sure if there's any actual regulations on the shelf life. The only time a shelf life would come into play would be with, microbial life inoculated stuff.
Yeah.
Biochar itself is going to stay in that form well past our lifetime, so it's not an issue there. But if you were to inoculate it and guarantee some sort of concentration of specific beneficials, that would be something that I would have a question about. You'd have to do some further research and analysis on it. As far as charging with nutrients, and the nutrients, it shouldn't affect it. I
I know there's all that, I guess there's so many variables. I just figured I'd ask. And my last question would be, I know you guys want to cut this off, cut it. It's almost 7 now. Is this a good way can we use this in like hydroponics? Say you're using beaver trays. Would it be smart to use the biochar in some way, or would that be something to stay away from? Like, because it's such like small amounts of soil you're using to get seed started.
Yeah.
So an overbearing thing to begin with, probably, I guess.
I've used it in an aquaponics system as as a replacement to like bio balls for a biofilter, and it worked great. I mean, it sticks around. I didn't crush it, it's not crushed so fine, or else it would, because we had it in fairly fine netting. But if it was crushed to a powder, it would just wash everywhere. So like in that context, it helped boost the surface area to volume for that nitrification to happen. In a hydroponic, specifically a hydroponic system, I mean, I think you could have some success in it. I haven't used it exclusively in a hydroponic system as a growing medium. I haven't done any of that. Biochar, as long as it's quality biochar, it generally does help boost germination rates. So if you're doing it to start stuff, it very well could help. It'll hang on to nutrients as well. So, that I could see it being a beneficial in hydroponic system. I've only used it in aquaponics as a biofilter medium.
All right, great. Yeah, because I'm thinking if I market say some biochar, I could do a double, I could do it for not just for people's crops, but also for hydroponics, and not just limit it to one use.
Right. Exactly.
If there is a use for it in hydroponics, it'd be nice to put on there, that'd be great,
Yeah. Yep. It's a good idea.
Thank you.
We have one more question before we wrap up, and that's from Cynthia, and she was just wondering, is there any benefit to having larger pieces of biochar? She's suggesting that maybe in hugelkultur to store water over a longer period of time.
Yeah. So there, as far as water holding capacity, I think it's actually an inverse relationship with the larger the pieces are, the less water holding capacity it has. It seems kind of funny, but because as you crush it up, you increase that surface area to volume ratio even more, and so it can hang on to water molecules a bit better. But there could be a benefit, something again we didn't really talk about here, but take, for example, if you're making you need to make your own potting mixes for nursery production. Sometimes you need to increase drainage in your soils, in your pots. And If you don't have vermiculite or perlite as an alternative, you can use biochar that's, similar sized or maybe a little bit larger chunks of it. And that will, make your soil mix lighter. It will actually help with drainage because you've opened up greater space in there and made a lighter mix. So that actually for drainage in pots can be helpful. If you're in some situation where you're making your own potting mix. We also, just one last thing about that, if anybody makes soil blocks for starting seeds, we use biochar in our mix for soil blocks as well. So it's helpful with making soil blocks if you're trying to get away from using plastic trays.
Awesome, thank you.
Yeah.
I hope everybody got their questions answered, and I'm gonna really quickly do one last big thank you for everybody to showing up and for Elliott for knocking these questions out of the park. So thank you so much to Echo and Elliott for all of your expertise. And I hope that you guys have a really wonderful evening. You can always contact Elliott himself or NCAT when you have questions about biochar and production. We both give free technical assistance, and we both have really fantastic free online resources for you all to access. So don't be shy and please reach out. Thank you so much, everybody, and have a really wonderful evening.